number 2g, we have cotan y over x root 4x squared minus 1. So these are separable, and when we separate this, we end up with this expression. So we end up with dy over cotan of y is equal to dx over x square root 4x squared minus 1. Now I'm going to rearrange this a little bit because we want to integrate this, both sides of this. And this is going to be a little bit harder to integrate, so I'm going to rearrange this to just tan y dy equals dx x root 4x squared minus 1. So on this left hand side, we want to separate this into sine y over cos y dy. And we need to use a substitution here to solve this. So I'm going to substitute, I'm going to let u equal cos y. Then du works out to be negative sine y times dy. And there's the piece that I want right there. So when I do that substitution, my new integral is going to look like this. It's going to be negative 1, so I'm going to put the negative out here. I'm going to replace the negative 1 du with the sine y dy. And in the denominator, I get u, and there's my substitution. Now I have a new integral in terms of u, which I can then solve. So this becomes negative log u plus c. So I'm going to avoid using the plus c right now because I'm going to put the plus c on the other side. So I have to back substitute my u because I wanted things in terms of the original y. So I get negative log cos y. Okay, so that's the left hand side of that integral. For the right hand side of this integral, I need to use this identity here. Now it doesn't quite look like, this is a cosecant, so if I want to integrate that I get cosecant x, but it doesn't quite look the same as here because I have 4x squared, but I can rewrite it like this. I can rewrite this as dx over square root 2x squared minus 1. That means that my input is 2x. That means this part needs to be 2x as well. But I don't have 2x, I have x. But if I want to make this 2x, what I can do is I can introduce a times 2 here, which is really a divide by 2, and a times 2 there. And now I have this in the same terms. This is my input 2x, my input 2x, and all I had to do was account for that extra 2 with something on the outside here. And by doing that, now I have an integral which I can anti-differentiate. I know the antiderivative using this definition is going to be cosecant, the inverse cosecant. So it's going to look like this. So I'm going to put my 2 on the outside here. That's going to become cosecant, the inverse cosecant, and my input is 2x, and I have to account for that by dividing by 2 because of the chain rule. And I'm going to put my plus c in here like that. So there it is. I have my integral solved for both sides. So I'm just going to simplify this. So cosecant, the inverse cosecant of 2x plus some c value. So at this point I'm going to solve for c by substituting in the x values. The x and y values, if I'm not mistaken, was y1 equals 0, so x equals 1, y equals 0, so I'm going to substitute that in. So I get negative y cosine of 0 is equal to the inverse cosecant of 2 plus c. Okay, so this is going to be negative log cosine of 0 is 1, log of 1 is 0, so the left hand side becomes 0. The right hand side, I'm going to change this to arc sine, and I'm going to use 1/2. Okay, so if I want the arc cosecant of 2, I want the arc sine of 1/2. Okay, so this is something that you might want to just kind of make sure that you're clear on going from here to here. Just make sure that's clear to you why I can do that. And then I can solve for the rest of this. The arc sine of 1/2. So if I take a look at where sine of 1/2 is, that's going to be this length here. So that angle is going to be pi over 6. So I end up with pi over 6 plus c. So c is equal to negative pi over 6. So that's what I'm going to end up with for my c here. So then when I rewrite my equation, I get negative log cosine of y is equal to the arc cosecant of 2x minus pi over 6. Solving for y, I get cos y is equal to, I'm just going to switch this around, so e is, I'm going to move the negative over to here and make it pi over 6 minus cosecant, the inverse cosecant of 2x. Okay, so that's my expression, and then I need to undo the cos with an arc cos. So this is e to the pi over 6 minus cosecant, the inverse cosecant of 2x. And there's my expression. This is the solution to that differential equation.